This Zoom session is being brought to you by the fractal inverse bullseye S swirl. I love presenting my fractals. I think they're pretty. We proceed. Section 4.4 is about area of a triangle, which is absolutely legitimate triangle measuring. And I'll start with some fairly obvious ones and then go on to a really heroic one, formula that is, for measuring the area. Okay, here's a triangle with base B, B for base, and we drop this perpendicular, height h. Now, this triangle fits inside a rectangle with base B and height h, and this area here equals this area here, this equals this, therefore the area of the triangle equals 1/2 the area of the rectangle. And the rectangle has area base times height, so area is 1/2 base times height. And for some reason, they settled on the letter capital K to denote area. I think it's probably because capital A is already used for angles. And maybe it's German for area or something, whatever. In the 19th century, the Germans weren't a nation yet, but they were scholars.
It wouldn't be K, then it would be F.
F?
Yeah,
Okay.
Fläche is German for area.
I stand corrected. Thank you. I have no idea then why they use the capital K. So
yeah, good question.
Good question. So anyhow, so area K is 1/2 base times height. I think they probably use all the letters up to it, up to J, and other things of the triangle. Whatever. Okay, so now let's start with a side angle side formula. So given a side and a side A and B, and the angle gamma between them, we draw the height h. H over A is sine of gamma, and so h over A equals sine. So h equals A sine gamma, and then plugging it into here, so A sine gamma for h, K is 1/2 AB sine gamma. And if you rotate labels A to B to C to A, gamma to alpha to beta to gamma, then K is also 1/2 BC sine alpha and 1/2 CA sine beta. This is the area of a side angle side triangle. 1/2 side times the angle between them. Okay, that's simple enough. Now here, however, okay, fine. Half of the triangles formulas we have involve at least some angles and at least one side, and we get side angle side eventually. But what about a side problem? So triangles A, B, and angle sides A, B, and C. What's the area? Well, it's named Heron's formula, or it's sometimes called Hero's formula, because it's a heroic formula. This was invented by Heron of Alexandria, one of the more remarkable cities in world history, named after Alexander, who founded it, and was famous for a library which contained all of classical knowledge, and which was burned accidentally by Caesar and deliberately by some Christians and deliberately by some fanatical Muslim. Crime against humanity. Fortunately, some of its contents were saved elsewhere. Anyhow, so given us triangle sides A, B, and C, let S be the semi-perimeter, half of the sum, A plus B plus C over 2. Then K equals the square root of S times S minus A times S minus B times S minus C. Heron's formula. Now, right here, we're going to go through a fairly complicated proof. And if you want to take another look at it, it's available in the book, and online. There are an even number of derivations. Excuse me. That was my cat. That man's a treat. All right, here we go. Let's start. We start with the law of cosines. C squared equals A squared plus B squared minus 2AB cosine gamma. And the half angle formula is the square of the cosine of gamma over 2 is 1 plus cos gamma over 2. So cos square gamma over 2, 1 plus cos gamma over 2, and then we use what I've called the the cosine gamma is A squared plus B squared plus minus C squared over 2AB, what I call the arc cosine law. And then you keep going with a bunch of algebra, and you get A squared plus B 2AB plus B squared minus C squared over 4AB. This follows directly from this after some reasonably tedious algebra. And this a squared plus 2ab plus b squared is a plus b all squared minus c squared over 4ab. And since this is the difference of squares equals the difference times the sum. A plus b minus c times a plus b plus c over 4ab. And then this, after some mildly tedious algebra, becomes 2 times s minus c for this, 2 times, oh, obviously this is twice s, and that reduces to s minus c times s over ab. And likewise, sine squared of gamma over 2 is 1 minus cos gamma over 2 is 1 minus a squared plus b squared minus c squared over 2ab all over 2. And this we can do some algebra 2, and this we do some algebra 2. And then after algebra rather like this, and I won't bother to go into bore you too much with the tediousness of it, cancel some 2's, we get s minus a times s minus b over 2ab. So this is the square of cosine gamma over 2. This is the square of sine gamma over 2. Now, K, the area, is a half AB sine gamma, and sine gamma is twice gamma over 2. So a half AB sine of twice gamma over 2. And the double angle formula says that the sine of twice gamma over 2 is twice sine gamma over 2 cosine gamma over 2. The half and the 2 cancel. We get AB sine of gamma over 2, cosine gamma over 2. Okay. And this from here is the square root of s minus a times s minus b over ab, like here. And this cosine gamma over 2 is the square root of s times s minus c times s over ab. Okay, merge these two, get ab root s times s minus a times s minus b times s minus c over ab. AB is canceled, and we're left with this. K equals root of s times s minus a times s minus b times s minus c. And that's Heron's formula, Hero's formula, Hero's heroic formula. And this gives the area of side-side triangles. All right, then. Now we have some examples. Let's start with a triangle with a equals 3 and b equals 4 and gamma equals 40. What's K, the area? Well, it's a half AB sine gamma, a half times 3 times 4 times sine 40 degrees. Tick, 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 on your calculator, and you get K is approximately 3.856. I'd like at least 4 significant figures in your answers. A equals 3, C equals 2, beta equals 110. Likewise, K is a half times 3 times 2 times sine 110. And calculator, tick, 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 2.819 approximately. Now for a side problem. A equals 5, B equals 8, C equals 9. All right, fine. First, the semi-perimeter, 5 plus 8 plus 9 all over 2 comes out to be 11. So K equals S root of S times S minus A, S minus B, S minus C. That's 11 times 11 minus 5 times 11 minus 8 times 11 minus 9, and take the square root. You get the square root of 396, which is root of 36 times 11. Root 36 is 6, so you get K is 6 root 11, or approximately 19.8997. Here we have, and the book has one of those word problems with a 4-color photo of a famous building in New York City, and they do these 4-colored photos, which really don't have any mathematical content. I suppose to improve the appeal of the book, I suppose, but really to improve the sales price. But I digress. The side of it's a triangular building because it's in a triangular block. Size 173 feet by 87 feet by 190 feet approximately. What's the area? Okay, fine. What's the floor area? All right, fine. Semi-perimeter is 173 plus 87 plus 90 all over 2, which is 225 feet. K equals S, root of S times S minus A, S minus B, S minus C. So root of 225 feet times 225 minus 173 feet times 225 times 87 feet times 225 times 90 feet. If you do all the arithmetic, it's let's see, what is that? 56,511,000 fourth power of feet. Feet times feet times feet times feet. Well, okay, take a square root. Root 56511,000. A square root of a fourth power is a second power. Root 57511,000 square feet. And by the way, I am astonished that Heron was willing to even contemplate the concept of a fourth power of a unit of length. The Greeks generally didn't tried to avoid high. They generally didn't believe in dimensions beyond 4. So here's tesseract feet units, but we take a square root, so it turns into square feet. And after a square root, it's approximately 7,517.4 square feet. This 0.4 is probably more accurate than is required. We're only told this down to unit feet, not tenths of feet. So this is a little bit more than needed, but I'll do it anyhow. Okay, so there we have that. The formulas are routine. Here we go. Here's this hard classic, and this simple, very classic, and these of moderate difficulty classic. So there we have it. Okay, let us conclude the recording.